Tonight, we are going to talk about the place many people imagine as humanity's first real home beyond Earth: the Moon. It is close, familiar, and bright enough to follow us through the night, which makes the idea of building a base there feel almost reasonable. Compared with Mars, the Moon seems like the easier step, only a few days away, close enough for rescue, communication, and the sight of Earth above the horizon. But that closeness hides a harsher truth. A moon base would not sit on a gentle world waiting to be settled. It would be built on an airless surface covered in dangerous dust, exposed to brutal temperature swings, radiation, micrometeorites, and an isolation that may feel worse because home is always visible, but still impossible to touch. So tonight, the question is simple. Why would building a moon base be worse than Mars? Before we begin tonight's journey, subscribe if you want more calm space documentaries like this. Leave a like if you enjoy deep space mysteries, and write in the comments where you are watching from. Tonight, you are watching the Space for Sleep channel talking about why building a moon base would be worse than Mars. From Earth, the moon feels almost close. It hangs above our nights with a kind of quiet familiarity that no other world has. It is not a tiny red point like Mars, not a distant dot lost among the stars, and not a place we only know through robotic images from millions of kilometers away. The moon is visible with the naked eye. It follows us through streets, windows, oceans, deserts, and dark fields. It brightens the night enough to cast shadows. It changes shape with the passing days. It feels like part of Earth's own rhythm, as if it belongs to us more than any other place in space. That familiarity is what makes the idea of a moon base feel so natural. When people imagine the first real human home beyond Earth, the moon often seems like the obvious beginning. It is close enough that astronauts have already walked there. It is close enough that a spacecraft can reach it in days instead of months. It is close enough that communication delays are small, that Earth remains visible in the sky, and that rescue, at least in imagination, feels possible. Compared with Mars, the Moon seems like the safer, simpler, more reasonable first step into deep space. This is where the illusion begins to break. Mars feels dangerous because it is far away. It is another planet, separated from Earth by millions of kilometers, with its own reddish deserts, dust storms, thin atmosphere, and long communication delays. The danger is obvious. It looks alien even in photographs. The Moon is different. It looks calm from Earth, because we see only its light, its phases, and its familiar face. We do not feel the vacuum. We do not feel the cold. We do not feel the dust clinging to machinery. We do not feel the radiation crossing the surface with almost nothing to stop it. Distance makes Mars frightening. Familiarity makes the Moon deceptive. A moon base would not be a little outpost on a nearby island. It would not be like building in Antarctica, a desert, or the bottom of the ocean, even though those places are already extreme by human standards. On Earth, every remote place still sits inside Earth's protection. Antarctica has air. Deserts have an atmosphere. Oceans have pressure and water. Even the most hostile terrestrial environments are still wrapped in the same planetary system that keeps life possible. The Moon has none of that comfort waiting outside the wall. Outside a moon base, there would be no breathable air, no weather in the Earth-like sense, no open water, because from Earth, the Moon looks peaceful. It looks like a place you could stand and look back at home. And in one sense, that is true. The Apollo astronauts did stand there. They walked, worked, collected rocks, took photographs, drove a rover, and saw Earth hanging in the black sky. Those moments became some of the most powerful images in human history. They made the Moon feel reachable, almost familiar, almost conquered. But visiting a place is not the same as living there. A short mission can survive by carrying nearly everything it needs. It can accept risk for a limited time. It can rely on careful timing, mission control, stored supplies, and a plan to leave. A base is different. A base means staying. It means returning again and again. It means sleeping there, working there, repairing systems there, and trying to make a tiny human bubble endure on a world that offers almost nothing freely. That is where the moon becomes more frightening than it first appears. The problem is not only that the environment is harsh, the problem is that the environment never stops being harsh. On Earth, a building can fail in many ways and still not instantly become lethal. A window can break, and the air remains outside. A power failure is dangerous, but not usually the immediate removal of pressure, oxygen, and temperature control. On the moon, every ordinary failure becomes more serious because there is no natural backup. Earth does countless things for life every second without anyone noticing. It holds an atmosphere around us. It shields us from much of the sun's harmful radiation. It spreads heat through air and oceans. It provides pressure for our bodies. It gives us gravity strong enough to shape our biology. It cycles water. It softens meteorites. It gives sound a medium to travel through. It gives weather, soil, and a sky that changes color instead of opening straight into darkness. A moon base would have to create a small artificial version of some of those protections inside metal, glass, regolith shielding, sealed rooms, pipes, sensors, filters, pumps, batteries, radiators, and backup systems. That is why the phrase "closer than Mars" can be misleading. The moon's closeness solves some problems, but it does not make the surface friendly. It shortens the journey. It reduces communication delay. It makes supply missions more realistic. It keeps Earth visible. Those are enormous advantages, and they are part of why humans may build there before Mars. But closeness is not habitability. A world can be nearby and still be brutal. In some ways, closeness may even make the moon more psychologically cruel. Mars is distant enough to feel like a separate world. If humans lived there, Earth would become a bright point in the sky, emotionally powerful but physically remote. On the moon, Earth would be huge, blue, alive, and almost unbearably visible. It would hang above the lunar horizon like home itself, close enough to see continents and clouds, close enough to remind every person inside the base what they left behind, yet still unreachable without machines, launch windows, fuel, and survival systems. The moon would keep home in sight. But before the psychological part becomes clear, the physical truth has to settle first. The moon is not Mars with a shorter commute. It is a different kind of emptiness. Mars at least has a thin atmosphere, even if it is far too thin and carbon dioxide rich for humans to breathe. Mars has weather, pressure, dust storms, and a day length not too different from Earth's. It feels, in certain ways, like a world with systems. Hostile systems, but systems. The moon feels more like exposed space with ground underneath. That is a severe difference. Standing on the moon would mean standing in a place where the sky is black even in daylight, because there is no thick atmosphere to scatter sunlight into blue. Shadows can appear intensely dark. Sunlit surfaces can become extremely hot, while shaded regions can become dangerously cold. There is no air to soften transitions, no wind to carry heat, no atmosphere to blur the line between sunlight and shadow. The environment is simple in the most unforgiving way. Pressure or vacuum. Inside or outside. Alive or dead. A base built in that environment would not feel like a town at first. It would feel like a machine that humans happen to inhabit. Every corridor, sleeping area, laboratory, storage room, and airlock would belong to one larger survival system. The walls would not just separate rooms, they would hold pressure. The doors would not just open and close, they would protect air. The floor would not just support footsteps, it would sit above a dead surface, where human skin, lungs, and blood cannot survive unprotected. This is why the first moon base might be visually impressive from far away and claustrophobic from inside. In concept art, lunar bases often look clean and calm. Glowing domes, smooth modules, solar panels, astronauts walking gracefully under Earthrise. But the lived reality would likely be more cramped, mechanical, dusty, noisy, and repetitive. The people inside would not be strolling through a futuristic city. They would be managing a controlled environment under constant threat from the outside. The moon would not be waiting to be settled. It would be waiting to break whatever we build. That does not mean a moon base is impossible. It means it is harsher than the romantic version. Humans can engineer extraordinary things when the goal is clear enough. We have already placed stations in orbit, landed machines on other worlds, and returned astronauts from the moon. We may learn to use lunar resources, bury habitats under regolith, protect crews from radiation, manage dust, generate power, recycle air and water, and build systems that endure for long periods. But every success would be earned against the environment, not given by it. The moon offers location. It does not offer comfort. This is the central contradiction of the video. The moon is the nearest world, and because of that, it seems like the easiest world. But the things that make a place livable are not the same as the things that make it close. A world can be close enough to reach quickly and still be almost completely incapable of supporting human life without total artificial protection. That is what the moon is: nearby, visible, historically visited, emotionally familiar, and physically merciless. Mars is worse in some ways. The moon may be worse in others. The comparison is not simple, and that is what makes it interesting. Mars is farther, colder, more difficult to supply, and much harder to rescue from. A Mars colony would face enormous isolation and technical danger. But Mars also gives humans a larger world, a horizon, a thin atmosphere, a roughly Earth-like day, seasons, landscapes, and the psychological feeling of being on a planet. The moon gives closeness, but it also gives a kind of exposure that may feel more severe. A moon base would always be a small artificial pocket against pure emptiness. That is the image to keep in mind. Not a colony spreading naturally across a landscape. Not a settlement growing like a town on Earth. At least at first, a moon base would be a sealed pocket of air, pressure, light, warmth, water, and human routine, surrounded by vacuum and dust. The people inside would depend on the pocket every second. The moon, outside, would remain indifferent. This is why the first step into lunar living may be less like moving into a new world and more like living inside a spacecraft that happens to be resting on the ground. The ground itself does not make it safe. The nearby Earth does not make it easy. The beautiful view does not make it home. And that is where the deeper unease begins. A moon base would prove that humans can extend life beyond Earth, but it would also prove how much of life is Earth doing the work for us. The moment we try to live where Earth's protections are gone, we discover that a home is not only a location. It is a whole planetary system holding us in place. The moon has a location. Earth has a living system. A base would have to bridge that difference with engineering. For a while, that may work. People may live there for weeks, months, perhaps longer. They may conduct science, test technologies, mine resources, build shelters, and prepare for deeper missions. The moon may become a proving ground, a laboratory, a launch point, a symbol of human endurance. But none of that means it will feel like home. It may instead feel like the most expensive reminder ever built that Earth is not easily replaced. That is the quiet terror of a moon base. Not that it cannot be built, but that building it may reveal how unlivable even our nearest neighbor really is. The moon is close enough to tempt us, bright enough to comfort us, and familiar enough to make us underestimate it. Yet, on its surface, every human need becomes a technical problem. Air becomes a system. Water becomes a supply chain. Warmth becomes engineering. Safety becomes shielding. A doorway becomes a pressure boundary. A scratch, a leak, a filter failure, a dust problem, or a power loss becomes part of the daily mathematics of survival. That is why the story begins with the moon looking easier than Mars. It has to begin there, because that is the illusion most people carry. The moon is near, Mars is far. Near must be easier. But when the surface itself is considered, the answer becomes darker. The moon's closeness helps humans arrive, but it does not help humans breathe. It helps messages travel, but it does not protect the body. It lets Earth remain visible, but it does not make Earth reachable by hand. The easiest place to reach may still be one of the hardest places to live. That is the thought that should follow the viewer into the rest of the journey. The moon is not a gentle stepping stone. It is a silent test of whether human technology can replace the invisible work of a planet. It is close enough to make the dream feel possible, but empty enough to show how fragile that dream really is. And to understand why that emptiness is so dangerous, we have to begin with the one thing the moon almost completely lacks: air. Air is so ordinary on Earth that it becomes invisible. It is around us every second, pressing gently against the body, filling the lungs, carrying sound, moving heat, scattering sunlight, shaping clouds, softening the sky, and making the outside world feel continuous with the inside world. A person can leave a house, open a window, walk across a field, stand on a mountain, or sleep under trees without thinking that the atmosphere is holding them alive. On Earth, air feels like nothing because it is always there. On the moon, that nothing is missing. That is the first and most brutal difference between a place that looks close and a place that can actually support life. The moon has an extremely thin exosphere, a scattering of particles so sparse that for human survival it may as well be vacuum. It is not an atmosphere in the way people usually imagine one. It does not wrap the moon in a protective blue layer. It does not let you breathe. It does not provide pressure for your blood and tissues. It does not carry weather across the surface or soften the raw edge of space. Remove that pressure, and the body is no longer in the environment it was made for. A moon base would therefore need to create not only breathable air, but an entire pressure world. Every room would have to hold an artificial atmosphere inside it. Every wall, window, hatch, seal, pipe, and joint would become part of the boundary between human biology and lunar emptiness. The air inside would not be background. It would be stored life. It would be inventory. It would be something measured, filtered, recycled, watched, and defended. That is a strange way to live. A door on Earth can be opened casually. A door on the moon would be part of a controlled sequence. You would not simply walk outside. You would move through an airlock, check systems, seal compartments, manage pressure, protect the base atmosphere, and step into a suit that becomes a tiny personal spacecraft. The act of going outside would not feel like leaving a building. It would feel like leaving life support. Every exit would be serious. Every return would matter. That constant seriousness would shape the psychology of living there. Even if crews became used to it, the knowledge would never fully disappear. Outside is not outdoors in the Earth sense. Outside is the absence of the conditions your body needs. The surface may look wide and open, but freedom there would depend on a suit, oxygen, cooling, heating, communications, dust control, power, and time limits. The horizon might stretch beautifully, but the person looking at it would be trapped inside layers of engineered survival. The moon gives space to look at. It does not give space to live in. An astronaut would hear through the suit, through contact, through radio, through the body, through machinery. But the lunar landscape itself would not speak in air. A rock falling nearby would not make a familiar sound unless vibration reached through contact. A distant movement would not call out. There would be no wind, no rustle, no atmospheric whisper, no soft background presence. The surface would appear visually open and yet acoustically dead. That kind of silence could become unsettling. The danger is not only that humans cannot breathe outside, it is that every breath inside is artificial and enclosed. Every human body would live inside a manufactured pocket of atmosphere, separated from vacuum by materials and maintenance. There would be no open-air backup, no emergency step outside to breathe, no breathable valley, no weather shelter, no natural pressure zone. The base is the environment. There is no second environment waiting beyond it. This makes redundancy essential. A lunar habitat would need backup oxygen systems, backup power, backup carbon dioxide removal, backup seals, backup sensors, backup emergency shelters, backup procedures, and enough spare parts to handle failures that cannot be solved quickly from Earth. The Moon is close compared with Mars, but close does not mean immediate. A rescue still requires launch preparation, trajectory, landing, and survival until help arrives. The base must stay alive long enough for any outside help to matter. Air would be one of the most precious resources on the Moon. On the Moon, air is infrastructure. That one change turns living into management. You do not simply breathe. You participate in a system that allows breathing. You do not simply open a door. You protect the system. You do not simply sweep dust. You prevent particles from entering the air people will inhale. You do not simply sleep. You trust that the habitat will keep pressure, oxygen, carbon dioxide, humidity, and temperature within safe limits while you are unconscious. The lack of air also means there is no natural protection from small impacts in the way Earth's atmosphere protects us. On Earth, many tiny meteoroids burn up before reaching the ground. The atmosphere takes the hit silently above us. The Moon does not have that shield. Micrometeorites can reach the surface directly, striking at high speed. For a base, this means the habitat must be protected against small impacts that could damage materials, equipment, solar panels, radiators, suits, and exposed systems. A tiny object becomes dangerous when there is no air to stop it, because the environment outside offers no cushion. Air is also what makes fire behave in familiar ways, and inside a moon base, fire safety would become especially serious. The outside is vacuum, but the inside must contain oxygen and pressure. That means the base creates the conditions for human life, and those same conditions can create the possibility of fire inside an enclosed space where escape is complicated and smoke is dangerous. On Earth, a fire is terrifying enough. In a sealed habitat on the Moon, smoke, toxins, heat, oxygen management, and limited evacuation options would make it a very different kind of emergency. The life-giving atmosphere must also be controlled so it does not become a threat. This is one of the hardest truths about artificial environments. The same system that saves you can endanger you if it fails in the wrong way. Too little oxygen and people cannot breathe. Too much oxygen in the wrong context and fire risk changes. Too much carbon dioxide and thinking becomes impaired before danger is fully understood. Too much humidity and equipment or health can suffer. The atmosphere inside a moon base is not just air, it is chemistry under constant supervision. Every breath would be part of a balance. The moon outside would not care if that balance failed. It would not dilute bad air. It would not provide fresh wind. It would not vent smoke safely into a breathable outside world. It would not replace lost pressure. The base must solve everything internally. That closed nature could become emotionally heavy, especially over long stays. People are used to knowing that if a room feels stuffy, they can open a window. On the moon, opening a window is not relief. It is catastrophe. Comfort on Earth often comes from connection to the outside. Fresh air, sunlight through a window, wind, open doors, the smell after rain, night air, morning cold. On the moon, the outside is visually magnificent, but physically forbidden. A window might show Earth, stars, and the grey surface, but it cannot open. The view may calm the mind and also remind it of confinement. The person inside is not separated from outdoors by lifestyle. They are separated by survival. A sealed window looking over the lunar surface would be one of the most beautiful and lonely objects ever built. That is why the moon's lack of air becomes more than a technical detail. It shapes architecture, movement, sound, psychology, emergency planning, daily routine, and the feeling of the place. It decides how people enter and leave. It decides how habitats are built. It decides how much trust people must place in machines. It decides how dangerous dust becomes when carried inside. It decides how fire, leaks, pressure, impact, and contamination are understood. Almost every lunar problem begins or worsens because there is no real atmosphere. Without air, there is no breathing. Without air, there is no weather shield. Without air, there is no soundscape. Without air, there is no natural heat transport. Without air, there is no simple outside. The moon is not simply missing one ingredient. It is missing the medium that makes Earth feel like a continuous world. On Earth, air connects everything. It moves between forests and cities, over oceans and mountains, through open windows and across human skin. It makes the sky blue and carries the smell of rain. It lets voices travel without radios. It allows fire, flight, weather, clouds, and breathing. It makes the planet feel alive even where life is sparse. On the moon, that connection is absent. The world becomes separated into sealed human interior and lethal exterior. That separation may be the true beginning of lunar unease. A base is not just a building on the moon. It is a boundary between two realities. Inside, human time continues. Meals, sleep, work, conversation, experiments, repairs, boredom, worry, routine. Outside, the moon remains airless, silent, and indifferent. The two realities touch at the wall, but they do not mix. They cannot mix without danger. A lunar base would therefore be a place where every person knows the wall matters. On Earth, walls create privacy and shelter. On the moon, walls create atmosphere. That is a much heavier meaning. It means architecture becomes biology, engineering becomes weather, maintenance becomes survival. The base is not a home placed in an environment. It is the environment. Every person living there would be inside a human-made pocket of conditions that Earth normally provides for free. This is why the moon's nearness can be so misleading. Seeing it in the night sky makes it feel emotionally connected to Earth, but its surface is disconnected from almost everything the human body expects. The moon is close in distance but far from life. It is near enough to visit and almost impossible to inhabit naturally. Its silence is not peaceful in the way a quiet forest is peaceful. Its silence is the silence of no air. A forest is quiet and alive. The moon is quiet because sound has nowhere to travel. That difference matters. It means that even beauty there would have a strange edge. The black sky, the grey horizon, the distant earth, the sharp shadows, the still landscape, all of it would be visually unforgettable. But the beauty would be surrounded by absence. You could not smell the ground. You could not feel wind. You could not hear the landscape. You could not breathe the place. You could only experience it through a suit, a window, a radio, or a camera. The moon would be seen more than felt, and when it is felt, it would be felt through equipment. That may make lunar living psychologically difficult in ways that are hard to predict. Humans are sensory creatures. We do not only need oxygen and calories, we need environments that give feedback. Air moving across skin, distant sounds, smells, temperature gradients, open space, and natural variation all help the mind locate itself in a world. On the moon, many of those cues would be absent or artificial. The base would have to simulate enough comfort to keep people healthy, not only physically, but mentally. The absence of air becomes an absence of atmosphere in every meaning of the word. Not just gas, mood, texture, worldliness. Mars may be hostile, but it has a sky shaped by dust and air. It has sunsets with color, wind that moves particles, and an atmosphere thin enough to be deadly, but present enough to give the planet a kind of environmental character. The moon has the stark purity of exposure. Its sky is black, its shadows are sharp, its silence is total outside the suit. Its surface feels less like a damaged Earth and more like Earth's protection has been removed completely. That is why building there may be worse than people think. The moon is not only a place without air, it is a place where the absence of air turns every other problem into something harsher. A human base would have to create pressure before comfort, atmosphere before community, sealed safety before exploration. It would have to make inside meaningful, because outside is not livable. It would have to turn machinery into weather and walls into sky. It would have to defend its air against vacuum every second of every day. And once we understand what it means to live without air, the next danger becomes the way the moon handles heat and cold. On Earth, temperature feels like something the world helps manage for us. Even when the weather becomes dangerous, the atmosphere still spreads heat, carries wind, moves moisture, softens sunlight, and keeps the planet from behaving like a bare rock in space. A hot day can be brutal, but air moves around the body. A cold night can be dangerous, but the ground, clouds, oceans, and atmosphere all participate in the slow exchange of heat. Earth is not gentle everywhere, but it is wrapped in systems that keep temperature from becoming a simple fight between sunlight and darkness. The moon has no such wrapping. There is no thick atmosphere to move warmth from one place to another. No ocean to store heat. No clouds to shade the surface. No weather to distribute energy. No wind to soften the difference between sunlit ground and shadow. The lunar surface receives sunlight directly, loses heat directly, and leaves every object sitting there to handle the contrast almost alone. It is not weather in the Earth sense. It is exposure. And between those two states, a base must keep human beings at a narrow, survivable temperature, hour after hour, day after day, without help from the world outside. That is the trap. A habitat on the moon cannot simply be warm inside. Because people are warm inside, heat has to be moved, stored, rejected, conserved, and controlled. Machines produce heat. Human bodies produce heat. Electronics produce heat. Sunlight heats exposed surfaces. Shadow cools them. The base must protect itself from overheating while the sun is up, and from freezing while the darkness lasts. It must be both shield and furnace, both refrigerator and blanket, depending on where it is, what time it is, and what systems are running. On Earth, buildings already do this in smaller ways. For humans, that rhythm would already feel strange. The body is built around cycles of light and dark, close to 24 hours. Sleep, hormones, mood, alertness, and routine all depend on environmental signals that Earth gives almost automatically. On the moon, the natural rhythm would be wrong for human biology in many places. A base would have to create artificial lighting schedules, artificial mornings, artificial evenings, and artificial separation between work and rest. Outside, the sun might remain above the horizon for days, or the landscape might remain black for days. Time itself would have to be manufactured indoors. That psychological layer sits on top of the physical one. During the long lunar day, astronauts might know that outside the base, the surface is being heated by relentless sunlight under a black sky. During the long night, they might know that beyond the walls, the landscape has fallen into deep cold, with the Earth glowing above certain regions, like a distant reminder of the planet where day and night feel normal. The base would need to maintain human time while the moon follows a rhythm that does not care about human bodies. This is another way the moon reveals the hidden kindness of Earth. On Earth, the day is almost perfectly suited to the life that evolved under it. Not because the planet was designed for us, but because we are the result of life adapting to that planet. Our bodies grew up inside Earth's cycles. The moon offers a cycle that belongs to a lifeless world. Living there means carrying Earth's rhythm inside a place that does not share it. The temperature problem is therefore not only about degrees. That refusal takes energy. Energy is one of the largest challenges in lunar living. During the long day, solar power may be abundant in sunlit areas, but during the long night, the problem changes. A base cannot simply turn off when darkness comes. It must keep life support running, maintain temperature, power communications, preserve equipment, recycle air, protect water, and keep people alive. Batteries, fuel cells, nuclear power, stored energy, or carefully chosen polar sites with more constant sunlight may all become part of the answer. But none of those answers is simple. A sunny ridge may help power a base. A shadowed crater may hold ice. But between them is terrain, darkness, cold, dust, communication limits, machinery stress, and the need to move resources through one of the harshest environments humans have ever considered working in. This is very different from the simple version of the moon base dream, where a settlement sits peacefully near useful resources and sunlight. In reality, the best place for power may not be the easiest place for water. The best place for water may be too cold and dark for simple operations. The best place for landing may not be the best place for long-term survival. A base has to solve geography, engineering, energy, heat, and human biology together. That is what makes it feel harsher the more carefully we think about it. At first, the moon seems easier because it is close. Then we remember there is no air. Then we realize that without air, temperature becomes brutal. Then we realize that the long lunar day and night make power difficult. Then we realize that the places that may help one problem can worsen another. Each answer opens another difficulty. This is how the moon resists becoming home. Then, imagine the long night. The sun is gone. The landscape outside is silent and cold. Equipment must be protected. Batteries drain unless another power source exists. Systems conserve heat. The base glows from within like a small artificial ember on a dead world. Inside, people sleep under electric lights and controlled air, while outside, the temperature belongs to a place without weather, without life, and without mercy. It is the moon being itself. That is why temperature is not separate from everything else. It touches power, mobility, construction, life support, communications, resource extraction, science, and emergency response. A rover that cannot operate through extreme cold limits exploration. A solar panel covered in dust and exposed to harsh cycles produces less power. A radiator that cannot reject heat properly affects the habitat interior. An airlock that experiences material stress becomes more than an inconvenience. On the moon, thermal control is part of survival architecture. The base must manage its own climate because the moon has none to offer. That phrase sounds simple, but it reaches into every corner of the settlement. Climate is one of the things humans almost never think about as a system, until it becomes unstable. On Earth, climate is the large background that shapes what can live where. On the Moon, there is no climate in the life-supporting sense. There are only cycles of illumination, shadow, radiation, and heat loss. A lunar base must import the idea of climate into its own walls. Inside a human climate, this narrow comfort is what would define early lunar life, not expansion. A moon base would expand only as fast as its ability to contain Earth-like conditions. More rooms mean more pressure volume, more air to manage, more heat to control, more power to supply, more walls to protect, more systems to maintain. Growth would not be as simple as building outward. It would mean increasing the amount of artificial environment that must be kept stable against vacuum, radiation, dust, and thermal extremes. That is why a moon city is much harder than a moon landing. A landing is temporary. A base is persistent. A city is an entire artificial ecology. Each step multiplies the thermal problem. More people produce more heat, need more living space, consume more energy, and require more redundancy. More equipment allows more activity, but creates more failure points. More surface area means more exposure. More ambition means more dependence on systems that must work in a place where the outside cannot help. This is where Mars begins to look different again. Mars is cold, dangerous, and distant, but its day is close to Earth's length. It has an atmosphere that, while deadly and thin, still creates weather and some environmental behavior. It has a sky, sunsets, and a planetary rhythm that may be easier for human psychology to accept. The moon's temperature rhythm is more alien in its simplicity. Long light, long dark, no air, no weather, no natural softening. The moon is not just a smaller Earth. It is a different kind of exposure. A base there would teach humans how to live not in a harsh environment, but inside a manufactured environment placed on a harsh surface. That difference matters. The goal would not be adapting to the moon the way humans adapt to cold climates or deserts. The goal would be preventing the moon from entering the habitat at all. The base survives by separation, not integration. That separation has a cost. It makes every comfort artificial, every day scheduled, every temperature chosen, every breath controlled, every hour dependent on power. The outside world becomes something to observe, mine, explore, and cross carefully, but not something to inhabit directly. A person can look at the lunar horizon and feel wonder, but the horizon does not offer shelter. The ground does not offer warmth. The shadow does not offer relief. The sun does not offer friendly daylight. Everything must be interpreted through engineering. The moon turns nature into a problem set. That may sound harsh, but it is exactly why the subject is so compelling. We are used to imagining space settlement as an expansion of human life, as if life naturally spreads once humans arrive. The moon reminds us that arrival is only the beginning. To stay, humans must recreate the invisible comforts of Earth in a place that lacks them at the most basic levels. Air had to be created. Temperature has to be controlled. Time has to be simulated. Power has to be stored. And all of it has to work together. This is why the temperature trap feels so important after the airless surface. Without air, heat behaves differently. Without weather, sunlight and shadow become extremes. Without a normal day-night cycle, human rhythm becomes artificial. Without oceans or atmosphere, there is no planetary buffer. The moon is not actively attacking a base. It is simply refusing to provide the background conditions life assumes. A dead world does not need to be violent to be dangerous. It only needs to be indifferent. That indifference is what a moon base would face every hour. The base may glow with human life, but the surface around it remains unchanged. The same grey dust, the same black sky, the same hard sunlight or deep cold, the same lack of air, the same silence. The temperature outside may rise and fall across extremes, but none of it carries meaning for the moon. It is only physics. For humans, it is survival. This is why living there could feel worse than the simple dream suggests. Not because one dramatic danger makes it impossible, but because every basic comfort becomes an ongoing negotiation. The right temperature in the room, the right heat rejection from the equipment, the right power storage for the night, the right insulation, the right suit controls, the right emergency procedures, the right location, the right balance between sunlight and shadow. Nothing about comfort would be automatic. And when comfort is not automatic, the mind eventually notices. At first, the technology may feel exciting. The base may feel like a triumph. The view may feel impossible. But after days or weeks, the deeper awareness may settle in. This place does not support you. The habitat supports you. The moon merely allows the habitat to sit there. That is a very different emotional relationship from living on a planet like Earth, where the world itself participates in keeping you alive. The moon is a surface. Earth is a system. That difference will return again and again through every problem a moon base faces. Air reveals it. Temperature deepens it. Power depends on it. Dust will make it worse. The more closely we look, the more the moon stops feeling like an easy first home and starts feeling like a test chamber built by nature. Close enough to reach, empty enough to humble us, and harsh enough to show how fragile human settlement really is. And after heat and cold, the next quiet enemy would be the dust waiting on the surface. At first, dust sounds too small to belong in the same story as vacuum, radiation, extreme temperatures, and the enormous difficulty of keeping people alive on another world. It sounds ordinary. Dust is something people wipe from shelves, brush from clothes, wash from windows, and sweep from floors. On Earth, it is annoying, but familiar. It gathers in corners, floats in sunlight, settles on shoes, and becomes part of the background of living inside a real world. Even in deserts, where dust can become harsh and overwhelming, it still belongs to an atmosphere, to wind, to weather, to a planet where water, erosion, and air have shaped the grains over time. Lunar dust is different. It did not form in the same softening environment that shapes dust on Earth. There is no rain on the moon to smooth it, no rivers to wear it down, no thick atmosphere to move it gently through long cycles of weathering. The surface has been broken down over immense time by impacts, micrometeorites, radiation, and the constant exposure of an airless world. The result is not just powder. It is sharp, clingy, abrasive, electrically troublesome material lying across the surface like a quiet trap. That makes it more unsettling. A storm passes. A leak can be found. A temperature problem can be measured. But dust becomes a slow invasion. It rides on boots, gloves, tools, suits, wheels, seals, containers, sample bags, airlock floors, rover parts, and every surface that crosses the boundary between outside and inside. It does not need to move by wind to become a problem. Humans and machines would move it for the moon. Every step outside could bring part of the surface back in. A base must keep vacuum out, manage pressure, control heat, and protect against radiation. But it must also defend itself from the ground itself. The surface is not neutral. The grey powder that makes the moon look soft from far away can become one of the most persistent enemies of long-term settlement. It is not alive, not intentional, and not dramatic. It is dangerous because it is physical, small, and everywhere. The danger is not only outside. The danger is what follows you back. This is why lunar dust can feel more personal than radiation or temperature. Radiation is invisible, temperature is environmental. Vacuum is absolute, but dust touches everything. It gets onto the suit a person wears. It marks the gloves. It enters the cracks. It coats the boots. It travels with the astronaut, like a grey shadow. It is the moon clinging to the human attempt to separate inside from outside. And once inside, dust becomes a different kind of problem. The base air would be precious, filtered, recycled, and kept within safe limits. Anything floating in it would matter. If fine lunar particles entered the habitat, they could be breathed, carried into equipment, settle on electronics, irritate eyes, skin, or lungs, and create maintenance challenges in a closed environment where air cannot simply be replaced by opening a window. On Earth, dirty air can often be ventilated. On the Moon, air is managed. If the air is contaminated, the system must clean it. A small particle becomes part of life support. Inside and outside are human categories. The particles only follow contact, motion, static charge, and design failures. Dust would become the signature of living there. Not romantic dust, not soft dust, abrasive, clingy, ancient dust. Not through a single terrifying moment, but through repeated inconvenience that cannot be ignored because each inconvenience connects to survival. A stuck latch, a dusty seal, a contaminated glove, a clogged filter, a scratched visor, a rover part that moves less smoothly, a sensor giving strange readings, dust on a panel that should be collecting sunlight, dust on a camera lens, dust in places it should not be. Each small problem can sound boring. To live on the Moon, humans would have to interact with the very thing that makes living there harder. That is the trap. The base may need to hide beneath the material that contaminates its suits. It may need to build with the substance that scratches its equipment. It may need to process the ground that threatens its filters. Lunar dust is therefore not just an enemy outside the door. It is the raw material of any serious future there, and that makes the relationship more complicated. Humans would not simply defeat it. They would have to learn how to live with it, handle it, control it, shape it, and survive its side effects. That is much harder than planting a flag. The Apollo missions could leave. A base cannot keep leaving. A settlement has to develop habits, architecture, technology, and culture around the dust. There may be rules about where suits go, how airlocks are cleaned, how often filters are replaced, how rovers are maintained, how dust exposure is tracked, how health is monitored, how equipment is stored, and how construction zones are separated from living areas. The base would become organized around a material most people on Earth barely think about. This is another way the Moon would make humans humble. The Moon teaches that small things become large when there is no margin for error. On Earth, margin surrounds us. If dust enters a house, it is cleaned. If a machine wears down, it can be replaced. If a filter clogs, a window opens. If a tool fails, more tools can be shipped by road. If a person coughs from dust, fresh air is nearby. On the Moon, every replacement has a cost. Every repair takes planning. Every contamination can spread through a closed system, and every small inconvenience happens far from the industrial background that makes Earth feel easy. A replacement part is not in a nearby warehouse. A specialized technician is not down the road. A medical facility is not minutes away. Even if Earth can communicate quickly, communication does not fix a scratched seal, a damaged rover part, a clogged filter, or a dust-contaminated mechanism by itself. The crew must have the tools, training, and spare parts there, inside the same fragile outpost, being slowly touched by the lunar surface. This is why dust becomes a logistics problem. It returns after the next EVA, and the next. That repetition may shape the emotional experience of lunar life more than many people expect. Human beings can adapt to procedures, but procedures cost attention. If every journey outside requires dust protocols, every return requires cleaning, every maintenance task must consider contamination, and every surface slowly becomes coated or worn, the moon begins to feel less like a frontier and more like a place that resists every touch. A base on Mars would have dust too. Mars has serious dust problems, and its dust storms can be enormous. But Martian dust belongs to a planet with atmosphere and weather. Lunar dust belongs to an airless body where the particles have different history, different sharpness, different electrostatic behavior, and different consequences for pressure systems. The moon's dust does not arrive as weather. It waits on the ground and follows the explorers home. That quietness is part of the unease. No storm needs to rise. No wind needs to howl. The danger can begin with a boot step. Picture an astronaut returning from the surface after a long day of work. Outside, the landscape is still. The sky is black. Earth hangs above the horizon. The suit is coated with gray powder from the ground. The astronaut enters the airlock, and the base begins the careful process of protecting itself from the moon. Dust has to be removed, contained, trapped, or kept away from the living space. The person is home, but home must defend itself from the person's return. That is a strange inversion. On Earth, coming inside usually means safety. On the moon, coming inside could bring the outside with you. The airlock becomes almost ritualistic. Seal the door, check pressure, manage contamination, clean the suit, protect the filters, keep the habitat safe. Only then does the person truly return to human space. Over time, this ritual may become normal, but normal does not mean easy. It becomes part of the rhythm of a place where the boundary between life and death must be carefully maintained. Dust makes that boundary dirty. It turns the clean idea of a sealed base into something messier and more realistic. A moon base would not be a spotless science fiction room forever. It would be a working habitat, surrounded by regolith, machinery, maintenance needs, human fatigue, and the constant attempt to keep the external environment from degrading the internal one. Cleanliness would be engineering. Housekeeping would be mission safety. That is not the version people usually imagine when they look at the moon. From Earth, the moon looks smooth and quiet. Even through a telescope, its surface appears majestic. Craters, plains, shadows, mountains, bright highlands, dark maria. It does not look like a place where dust could become one of the central enemies of settlement. But the closer humans get, the more the romance becomes physical. The moon is not made of moonlight. It is made of rock, powder, glassy fragments, impact history, and abrasive ground. The beauty remains. But the beauty has edges. Those edges may be literal. Fine, sharp grains created by impact processes can behave differently from the rounded dust humans know on Earth. The particles can cling and scratch. They can be difficult to brush away. They can enter tiny spaces. They can turn repeated use into wear. A world without wind can still cover everything humans touch, because human activity becomes the wind. The base itself may become the weather system that moves dust around. Rovers stir it, boots carry it, landers blast it, tools collect it, machines process it, airlocks try to stop it, filters trap it. The moon waits. This is why serious lunar settlement cannot ignore surface operations. Even landings are a dust problem. Rocket exhaust near the surface can blow regolith outward at high speeds, affecting equipment, nearby habitats, solar panels, instruments, and landing zones. As bases grow, landing pads may become necessary not just for convenience, but to stop arriving spacecraft from sandblasting the very infrastructure they are meant to support. Even arrival disturbs the moon. The surface that looks frozen and silent can become hazardous the moment engines, wheels, boots, and machinery interact with it. Building a base, therefore, means learning to control not only the habitat, but the landscape around it. Paths, pads, berms, shields, cleaning zones, storage areas, and traffic patterns may all become part of dust management. A moon base would need urban planning before it ever became a city, because dust does not respect casual movement. That makes the moon feel less empty and more resistant. Its resistance is passive, but real. The surface does not move toward humans. Humans move into the surface, and the surface answers through particles, abrasion, contamination, and wear. That answer may be slow, but slow problems can be the hardest to solve because they become part of everything. Dust is not one obstacle on a checklist. It is part of the environment, the operations, the architecture, the health system, the power system, the maintenance plan, and the future construction strategy. It follows every ambition. If humans only visit, dust is a nuisance. If humans stay, dust becomes a way of life. That may be the most important distinction. Short missions can tolerate discomfort and degradation for a limited time. Long missions cannot. A settlement must survive repetition. The question is not whether a crew can endure dust for a few days. The question is whether a base can manage it for months, years, and decades through many crews, many machines, many repairs, and many expansions. That long-term view makes the moon harsher than the postcard version. It is not enough to land safely. It is not enough to keep warm. The base must remain functional while the surface tries grain by grain to enter and wear down the human-made world. This is why lunar dust belongs so early in the story. It reveals that the moon's danger is not only in grand extremes, but in details. The airless surface, the temperature swings, and the dust are not separate problems. They combine. No air means dust is not washed or weathered like on Earth. No air means it can cling and remain. Temperature swings stress the systems. Dust contaminates. Vacuum makes seals essential, and dust threatens seals. Every condition strengthens the next. The moon is not one problem. It is a network of problems. Dust is one of the threads tying them together. And once the dust is no longer just dust, the next truth is that a moon base would have to fight the moon every second. That fight would not always look dramatic. It would not always be an alarm, a cracked wall, a rover emergency, or an astronaut racing back to an airlock with oxygen running low. Most of the time, the fight would be quiet. It would be the steady hum of pumps moving air through filters, the slow work of radiators rejecting heat into black space, the soft vibration of life support systems maintaining pressure, the careful monitoring of power levels before a long shadow, the inspection of seals after dust exposure, the replacement of parts before they fail, the endless small decisions that keep a sealed human world from becoming part of the dead landscape outside. A moon base would not survive because the moon allows it to survive. It would survive because machinery refuses the moon. Inside, human life continues. Water comes from storage or recycling. Light comes from power. Safety comes from redundancy. Movement outside comes from suits. That shadow would follow the crew constantly. Even when nothing goes wrong, the awareness of dependence would be present. The astronauts might laugh, eat, work, exercise, send messages home, and watch Earth through a window. But beneath the normal rhythm would be a constant fact. The base is alive only while its systems keep a small artificial environment stable. If the systems stop, the moon enters. Not by moving. This is not a failure of the dream. It is the price of making the dream real. Every frontier story becomes less romantic when it becomes daily life. The first image is the arrival. The deeper story is how people remain there. On the moon, Remaining there means turning danger into schedules, checkups, parts lists, emergency drills, and maintenance logs. It means that survival is not a single achievement after landing, but a condition that must be rebuilt every day. The base survives today. A solar panel producing less power than expected, a water recycling system needing repair. It would be operated, and operation is where the moon becomes relentless. A building on Earth can be completed, handed over, and inhabited with occasional repairs. A moon base would always be in operation, always balancing inputs and outputs, always watching for small changes. Air pressure, oxygen level, carbon dioxide level, humidity, water purity, temperature, power storage, radiation dose, dust contamination, structural stress, communication health, suit readiness, emergency supplies. That relationship could become psychologically strange. On Earth, a person may feel that their home belongs to them. On the moon, the base may feel like something the crew belongs to. Its needs would shape their schedule. Its warnings would interrupt sleep. Its maintenance cycles would determine work. Its failures would become urgent. Its limits would decide how far people can travel and how long they can stay outside. The habitat would not be passive shelter. It would be the central organism of lunar life, and humans would be both inhabitants and caretakers. Every time a person looks through a window, they would see the reason the base must keep working. The gray surface, the black sky, the hard shadows, the distant Earth. Beautiful, but not breathable. Close to home, but outside human biology. The view might be calming for a moment, then quietly oppressive. It would show what has been achieved and what is still impossible. Humans have reached another world, but only by carrying a tiny artificial world with them. That is the paradox of a moon base. A base might be described as humanity leaving home, but in reality, it would be humanity taking home apart, into systems, and rebuilding a small version of it somewhere hostile. Atmosphere becomes tanks, filters, and pumps. Climate becomes insulation, radiators, and heaters. Water becomes recycling loops and storage. Soil becomes a research problem. Day and night become lighting schedules. Safety becomes checklists. The base is not the opposite of Earth. Solving one problem often creates another. Add more systems and the maintenance burden grows. Add more people and life support demand rises. Add more surface activity and dust exposure increases. Add more power generation and there are more exposed components to protect. This is the engineering spiral of lunar settlement. The moon does not present one obstacle that can be conquered once. It presents a network of constraints that interact with each other. A successful base is not the result of one brilliant technology. It is the result of many systems working together every day, while the crew manages the consequences of that complexity. That complexity may become the true cost of living there. Not only financial cost, mental cost, operational cost. A moon base would demand attention in a way Earth rarely does. On Earth, people can ignore many of the systems that keep them alive because the planet is stable enough in the background. On the moon, ignoring the system is dangerous. Life support is not background in the same way. Power is not abstract. Water is not assumed. Air is not free. Warmth is not guaranteed. The base would keep asking to be noticed. That constant attention could wear on people. The human mind needs periods when it is not monitoring survival. It needs rest, privacy, routine, distraction, and the feeling that the environment is not always one mistake away from becoming dangerous. A good moon base would be designed to reduce that burden, to make systems reliable, interfaces clear, alarms meaningful, and living spaces calm. But no design can erase the fact that outside the walls, there is no natural safety. The crew may relax. The base cannot. That is a quiet, powerful idea. The people inside may sleep, laugh, watch movies, exercise, talk to Earth, and experience moments of normal life. But the base must never stop doing its work. It must keep pressure stable while they sleep. It must keep air moving while they dream. It must keep temperature safe while they forget the surface outside for a few hours. It must keep power flowing through the long night, or under difficult conditions. It must remain awake for everyone. The base becomes the sleepless member of the crew. If it fails, everyone wakes into danger. That makes the moon feel less like a destination and more like a test of continuous reliability. Landing there is difficult, but staying there is a different category of achievement. The first days may be planned with extraordinary care. The first weeks may be watched by the whole world. But the true test begins when the base becomes routine, when the headlines fade, when the crew has done hundreds of small tasks, when equipment is no longer new, when the environment is not exciting anymore, but still just as lethal. That is when the fight becomes real. Not the first dramatic landing, the 1,000th ordinary maintenance check, the 10th dusty EVA of the month, the quiet decision to delay a rover trip because a seal does not look right, the boring repair that prevents a future crisis, the inventory count that proves enough spare parts remain, the alarm that turns out to be minor but must be treated seriously until it is understood. This is the real texture of an outpost on a dead world. It is not all terror, and it is not all wonder. It is discipline. It is patience. It is procedure. It is people trying to make normal life inside a place that cannot support normal life outside. That may be more impressive than the dramatic version, because it shows what human settlement actually means. Not just going somewhere, staying there without the world helping you. The moon would make humans earn every hour. And yet, this fight is exactly why a moon base might be built. A place this difficult can teach lessons no Earth laboratory can fully provide. It can show how closed life support systems perform under real off-world conditions. It can test construction methods, radiation shielding, dust mitigation, power systems, robotics, emergency protocols, and human psychology in a place close enough for support, but harsh enough to be meaningful. The moon is close enough to practice, but harsh enough to be honest. That honesty may be its greatest value. Mars is farther and more difficult to reach, so the moon may become the place where humans learn how bad their assumptions were. A lunar base could reveal which technologies work, which fail, which procedures are too slow, which materials degrade, which psychological stresses are underestimated, and which comforts matter more than mission planners expected. The moon would not flatter us. It would expose weaknesses quickly. In that sense, fighting the moon every second may be the point. A base there would be a rehearsal for deeper survival, not because the moon is easier in every way, but because its harshness is accessible. It lets humanity test the idea of living beyond Earth while still close enough to learn, fail carefully, repair, improve, and try again. That makes the moon both dangerous and useful. It is a hostile classroom, but a classroom can still be brutal. The lessons would come through failures, near failures, repairs, delays, fatigue, redesigns, and moments when the crew realizes that the moon is not a blank canvas for human ambition. It is a place with rules. Those rules are written in vacuum: dust, cold, heat, radiation, gravity, distance, and silence. Humans can operate within them, but they cannot ignore them. A moon base would have to respect the moon more than it conquers it. That is an important shift. The language of space exploration often talks about conquering frontiers. But the moon is not conquered by arrival. It is understood through survival. Every successful day would be less like a victory over the moon and more like a negotiated pause. The base keeps working, the crew keeps living, the systems hold, the boundary remains intact. Then the next day begins, and the fight continues. This does not make the dream hopeless, it makes it real. A moon base could be one of the most extraordinary achievements in human history, precisely because the environment is so unforgiving. It would prove that humans can carry a living system into a place where life has no natural foothold. It would be a triumph, not of comfort, but of persistence, not of ease, but of control. The danger is that people imagine it too softly. They see the moon glowing above Earth and think of a nearby world waiting for footprints, habitats, and flags. But a base would not be built on moonlight. It would be built on regolith, vacuum, extremes, procedures, and machines that cannot be allowed to fail casually. The romance is real, but it is incomplete. The moon is beautiful from far away because distance hides the work required to survive there. Up close, beauty becomes maintenance, and maintenance becomes life. That is the truth behind every future lunar outpost. The base would have to hold a small circle of Earth-like conditions against a world that never becomes friendly. It would have to fight the moon not with weapons, but with engineering, patience, and constant attention. It would have to turn survival into routine without letting routine become carelessness. If it succeeds, humans may begin to stay. If it fails, the moon will remain exactly what it has always been: silent, airless, dusty, and indifferent. That is why the idea of a moon base is so powerful and so unsettling. It is not simply a step toward the stars. It is the moment humanity discovers how difficult it is to recreate even the smallest piece of home. The base would be proof of our ambition, but also proof of our dependence. Every working system would say that humans are clever. Every risk would say that Earth is irreplaceable. And after seeing how hard the base itself would have to fight, the next problem is the one resource that makes every future plan sound easier than it really is: water. Water is the word that makes the moon sound almost practical. Whenever people talk about a permanent base, the idea appears quickly. There may be water ice near the lunar poles. Some of it may hide in permanently shadowed craters, where sunlight has not reached for enormous stretches of time. If humans can reach it, extract it, purify it, and use it, then water could support crews, help grow food, produce oxygen, and perhaps even become rocket fuel after being split into hydrogen and oxygen. Suddenly, the moon stops sounding like a dead rock and begins to sound like a place with resources. But that hope can be misleading. Water on the moon is not like water on Earth. Potential can inspire missions. It cannot be drunk. This difference matters because people often compress the story into a simple sentence: there is water on the moon. That sentence is exciting, and it is true in a broad sense, but it can create the wrong emotional picture. It can make the moon feel less hostile than it is, as if one of the biggest problems of settlement has already been solved by discovery. In reality, discovering a resource and building a civilization around it are separated by engineering, energy, time, risk, and failure. The moon may have water. A moon base still has to earn every liter. That contradiction sits at the center of lunar resource use. The moon does not offer water in a comfortable location simply because humans need it. It stores what it stores, according to physics, impact history, temperature, and sunlight. If useful ice is concentrated in permanently shadowed regions, then human plans must adapt to those regions, not the other way around. The resource decides where the difficulty begins. A base built near water would still not be simple. It might need to sit in a place where sunlight is available for power, while also remaining close enough to shadowed areas for ice extraction. That sounds logical on paper, but the terrain may be rough. Distances may matter, and every movement between light and darkness could involve equipment stress, navigation, dust, slopes, communications, and temperature extremes. A few kilometers on the moon are not like a few kilometers on Earth. There are no roads unless humans build them. No rescue vehicle unless humans brought it. No warm garage waiting unless humans constructed it. Even reaching the water becomes a mission. This changes the feeling of water from comfort to labor. On Earth, water is part of the background of life. It flows from taps, falls from clouds, moves through rivers, fills lakes, freezes in snow, and cycles through the biosphere. People may fight over it, waste it, cherish it, purify it, or transport it. But Earth is fundamentally a wet planet. Water belongs to the environment. On the moon, water would belong to operations. It would be measured in extraction rates, energy costs, storage capacity, purity levels, and mission risk. The moon does not hand water to humans. Humans must build an entire water industry in miniature. This is where the romance of lunar resources meets the fear of dependence. If a base depends heavily on local water, then water extraction becomes one of the most important systems in the settlement. If the extraction equipment fails, if the ice is harder to process than expected, if yields are lower than hoped, if contamination is difficult, if storage losses occur, if a transport rover breaks down, or if power becomes limited, the base may have to rely more heavily on supplies from Earth. That fallback may exist, but it changes cost, planning, and safety. The dream is independence. Water inside the base would not feel ordinary. It would feel precious. That could shape daily life in subtle ways. Showers, laundry, cooking, plant growth, cleaning, medical use, equipment maintenance, and emergency reserves all become water decisions. A person living on Earth rarely thinks about the entire chain behind a glass of water. On the moon, that chain would be impossible to forget. The water may have been launched from Earth at great cost, recycled many times, extracted from shadowed regolith, or saved carefully through systems that must keep working. Every sip would belong to engineering. This is why water is not only hopeful, it is also frightening. A world without easy water forces humans into dependence on systems they cannot ignore. Oxygen can be produced from water, but that means water becomes air as well as drink. Fuel can be produced from water, but that means water becomes mobility and escape. Plants can grow with water, but that means water becomes food and psychological comfort. The more uses water has, the more critical it becomes. One resource begins to carry too many dreams. Water is the most tempting half-answer of all. Because without water, long-term human life becomes far more expensive and fragile. With water, everything sounds more possible. Crews can drink, oxygen can be made, rocket propellant might be produced. Agriculture experiments become more realistic. Emergency reserves become more local. The moon becomes not merely a destination, but a platform. A place where humans do not bring everything, but begin to use what is there. That possibility is real. It is also not guaranteed to be easy. The careful middle ground is important. The point is not to say lunar water is useless. It may be one of the most important reasons humans return to the moon. It may decide where bases are built, how missions are designed, and whether the moon becomes a stepping stone for deeper space. But its importance is exactly why it should not be treated casually. The more important a resource is, the more dangerous it becomes to misunderstand it. There is another layer too. Extracting water from the moon may require disturbing areas that are scientifically precious. Permanently shadowed regions can preserve ancient records of lunar and solar system history. They may contain clues about impacts, volatile delivery, solar wind, and the long evolution of airless bodies. Mining them could be valuable for human survival, but it may also destroy or alter information that scientists want to study. A moon base would not only face technical questions, but ethical and scientific ones. How much of the moon should be used? How much should be preserved? Who decides? Those questions may sound distant, but they will become more important if lunar settlement becomes real. Water turns the moon from a place to visit into a place to use. And once humans begin using another world, even a dead one, the story changes. The surface is no longer only a scientific landscape. It becomes territory, resource, infrastructure, and political interest. The search for water may bring cooperation, competition, and conflict. The moon's emptiness may not prevent human complexity, it may concentrate it. A crater holding ice could become valuable. A ridge with sunlight could become strategic. A region with access to both could become the focus of national programs, private companies, scientific missions, and future settlement plans. The moon looks silent from Earth. But if water becomes important enough, parts of it may become contested, not because they are beautiful, but because they are useful. This is another reason the moon may be worse than people think. It is not only the environment, it is what the environment makes humans do. Scarcity changes behavior. On Earth, water scarcity already shapes politics, migration, agriculture, health, and conflict. On the moon, scarcity would be even more direct, because every resource has to be tied to survival and mission capability. A failed water system is not an inconvenience. A lost extraction site is not just lost profit. A contaminated supply is not just bad luck. The consequences can move quickly from economic to existential for a small base. That makes planning heavier. A moon base would need reserves, not just production. It would need multiple sources or fallback options. It would need careful accounting of consumption. It would need emergency water storage, separate from daily use. It would need systems designed for repair. It would need crews trained to survive if local water extraction stops. It would need a culture where waste is not just discouraged, but understood as risk. The base would not only use water, it would think about water constantly. That constant awareness could affect the people inside. On Earth, water can represent comfort, a bath, rain, a lake, a river, snow, the sound of waves, the smell of wet soil. On the moon, water may represent inventory, planning, and survival. The emotional meaning changes. A glass of water may still comfort a thirsty person, but it also carries the knowledge of how hard it was to obtain. A plant growing under artificial lights may feel beautiful, partly because the water feeding it was so difficult to protect. The scarcity may make small things more meaningful. A cup, a drop, a green leaf, a humid breath inside a sealed room. Those ordinary Earth experiences could become powerful on the moon, because they are no longer ordinary. They are controlled exceptions inside an airless, dry, hostile place. Water would become one of the strongest reminders that humans are not made for the lunar surface. We carry wet biology into a dry world. We bring bodies full of water to a place where water is hidden, frozen, scattered, and difficult. That contrast is almost haunting. The human body is soft, warm, pressurized, and mostly water. The moon is dry, cold in shadow, airless, and hard. A moon base is where those two realities are forced to meet. This is why the water problem belongs after dust and maintenance. By this point, the viewer understands that the base is not simply sitting on a friendly surface. It is fighting vacuum, temperature, dust, and system complexity. Water then becomes the resource that promises relief, but also reveals another layer of difficulty. The moon may give humans something they need, but only if humans build the machinery, choose the location, survive the cold, handle the dust, power the extraction, and protect the supply. There is no free water on the moon, in the way people feel water is free on Earth. There is only water that must be found, claimed, processed, and guarded. Even if future technology makes extraction easier, the fundamental difference remains. Earth gives water through a planetary cycle. The moon stores water as a fragile resource in harsh conditions. Earth's water moves through clouds, rivers, oceans, ice, soil, plants, and bodies. Lunar water, if used by humans, would move through drills, heaters, pipes, tanks, filters, electrolyzers, habitat loops, and mission plans. On Earth, water is nature. On the moon, water is infrastructure. That is the most important emotional shift. A moon base would depend on water, but water would not make the moon feel like Earth. It would simply make survival slightly more possible at the cost of new systems and new dependencies. The presence of water does not erase the vacuum. It does not soften the dust. It does not create an atmosphere. It does not make shadows warm. It does not turn the moon into a living world. It only gives humans one more thing to fight for. And perhaps that is the right way to see lunar water. Not as the solution that makes a moon base easy, but as the fragile beginning of something difficult. It is a reason to go, not proof that staying will be simple. It is a promise, but a promise hidden in darkness, cold, and regolith. It is the resource that may make lunar settlement possible, while also reminding us how far the moon is from being naturally habitable. The moon can hold water and still be dry in the human sense. It can offer fuel and still feel empty. It can support a base and still refuse to become a home. That refusal is what makes the next part of the story so human. Because even if the machines work, even if the air is controlled, even if the dust is managed, even if the water problem is partly solved, the people inside the base would still have to live with the psychological strangeness of being close enough to see Earth, and far enough that it cannot simply save them. That may be the cruelest part of the moon. Not the vacuum, not the dust, not the cold, and not even the constant dependence on machines. Those dangers are physical, and because they are physical, they can be designed against. Engineers can build walls, seals, filters, suits, shields, recyclers, airlocks, and backup systems. They can make plans for power failures and dust contamination. They can bury habitats under regolith, test life support systems, and prepare crews for emergency procedures. But the mind is harder to seal. A person living on the moon would not only be separated from Earth by space, they would be separated from Earth while Earth remains visible, bright, huge, and almost painfully close. It would not be a tiny star in the sky. It would not be an abstract home left behind somewhere in darkness. From many places on the moon, Earth would hang above the horizon as a blue and white world, full of oceans, clouds, continents, storms, cities, forests, voices, weather, families, and every open-air moment the human body understands. That closeness might sound comforting at first. It means communication is fast compared with Mars. It means the crew can talk to mission control without the long delays that would shape life on another planet. It means rescue or return is at least imaginable in days rather than months, if vehicles, timing, and systems allow it. It means Earth is not a hidden memory. It remains visible, almost like a guardian. But a visible home is not the same as an accessible home. The Earth in the lunar sky would be beautiful, but it would also be unreachable by hand. A person could not walk toward it. They could not open a door and feel its air. They could not hear its sounds directly. They could not smell rain, soil, oceans, kitchens, forests, cities, or anything living. They could only look at it through glass, suits, cameras, and screens. The planet would be close enough to fill the heart, but still separated by rockets, launch systems, schedules, fuel, risk, and vacuum. A lunar settler might not miss luxury first. They might miss air. They might miss weather. They might miss the fact that on Earth, a door opens into a world that wants the body to keep living. Nearness can make distance more painful. A person across an ocean feels far away, but reachable. A person behind glass in the same room can feel more painfully separated because the closeness makes the barrier obvious. The moon creates a cosmic version of that feeling. Earth is there, visible in the sky, but the barrier is not a window. It is space itself. It is vacuum, gravity, orbital mechanics, fuel, life support, mission schedules, and the fact that the human body cannot survive between worlds without technology. That might comfort them. It might also hurt. A crew member could speak to a child, a partner, a parent, or a friend, and then look out at Earth, knowing the person is somewhere on that glowing sphere. The conversation may be clear, but the distance remains. After the call ends, the person is still inside the habitat. The pumps still hum. The air is still recycled. The window still cannot open. The surface outside is still vacuum and dust. The mind may move home for a moment. Even the greatest view in human history may not be enough to erase confinement. There is a danger in assuming awe can replace comfort. The first sight of Earth from the moon may be life-changing. The 100th sight may still be beautiful. But beauty does not remove the need for privacy, space, routine, trust, sleep, movement, and psychological release. A person cannot live on wonder alone. The base must become livable, not just technically, but emotionally. It would need softness, not softness in the weak sense, but human softness. Places to rest, spaces that do not feel like machinery, lighting that supports sleep, sounds that do not constantly remind people of life support, private corners, shared areas that feel warm, plants if possible, meaningful rituals, and ways for the crew to feel that they are living, not only surviving. Without that, the base could function perfectly and still feel psychologically hostile. This could shape the emotional identity of a moon base. A base on Mars might eventually tell itself a story of becoming a new world. A base on the moon may tell a different story. A station at the edge of home, close to Earth, but outside its protection. It may become a place of work, science, testing, resource extraction and preparation, but not necessarily a place where people feel rooted. The moon may be too barren, too exposed, too connected to Earth, and too dependent on artificial systems to feel like a true home for a long time. It may feel like a threshold. That might be useful, but it is not the same as belonging. Belonging matters more than people sometimes admit. Humans are physical, emotional, social creatures. We bond with places through repeated experiences, smells, sounds, weather, seasons, routes, favorite corners, familiar light, the comfort of returning. The moon offers some of that, but in a severely altered form. The routes are inside modules or across dangerous terrain. The light is harsh or artificial. The sounds are mechanical. The weather is absent. The smells are controlled or filtered. The outside is not a neighborhood. It is a hazard zone. But learning a base is not the same as belonging to a world. That difference could create a quiet sadness inside the achievement. Humans may succeed at building a moon base and still discover that success does not feel like arrival. It may feel like holding a position, maintaining a foothold, keeping a flame alive in a place that cannot feed it. The accomplishment would be enormous, but emotionally, it may remain fragile. This does not mean people would hate living there. Some may love it. Some may feel purpose, pride, wonder, and a deep connection to exploration. Some may find the isolation peaceful. Some may look at Earth and feel more connected to humanity than ever before. Human reactions are not simple, but a settlement plan cannot assume that meaning and mission will erase stress. The moon's psychological pressure would be real because the environment makes ordinary human needs difficult to satisfy. The view of Earth may help. The view of Earth may hurt. Both can be true. That may be the deepest reason the moon-based story is different from a purely technical story. The machines can work, and the human being can still struggle. A base can maintain pressure and still not feel spacious. It can recycle water and still not feel alive. It can show Earth in the window and still feel far from home. The moon would test not only whether we can survive beyond Earth, but whether survival is enough. A sealed habitat with breathable air, safe temperature, filtered water, and working power is a miracle. But for long-term life, people need more than miracles of engineering. They need rhythms, meaning, connection, privacy, rest, nature or substitutes for it, and the feeling that their life is not only a mission. The moon makes that difficult, because everything natural must be imported, simulated, or remembered. A plant inside the base might become emotionally important not because it produces much food, but because it is alive. A small water sound, a recorded forest, an artificial sunrise, a shared meal, a private sleeping space, a message from home, or a view of Earth could become part of psychological life support. These things may seem secondary compared with oxygen and power, but over time, they become part of survival too. A human being does not only need to keep breathing. A human being needs a world. The moon does not provide one. It provides a surface where a world can be artificially held for a while. That is a hard truth to sit with. It does not make the moon worthless. It may make the moon one of the most important testing grounds humanity will ever use. But it also suggests that the first lunar base may feel less like the beginning of a new home, and more like a carefully defended island of life in a place that never stops reminding people where they truly came from. Earth in the sky would become the emotional center of that reminder. Every blue glow would say, "There is home." Every sealed wall would say, "You are not there." Every breath would say, "Something is keeping you alive here." This is why the moon could be psychologically worse than Mars in one specific way. Mars is farther, more dangerous to reach, and far harder to rescue from, but its distance may allow a new identity to form. The moon keeps old identity visible. It does not let Earth become only memory. It keeps Earth present and unreachable, like a thought that cannot be put away. For some, that may be inspiring. For others, it may be unbearable. A lunar base would have to prepare for both. It would need psychologists as much as engineers, routines as much as rockets, social design as much as structural design, crew selection, habitat layout, communication schedules, recreation, conflict resolution, privacy, artificial lighting, exercise, medical care, and connection to Earth would all matter. Not as luxuries, but as ways of keeping human minds stable inside an environment that was never meant to hold them. The moon would force humanity to admit that a settlement is not just hardware, it is people. And people are not as simple as machines. This is where the story becomes more intimate. A rocket can launch, a module can land, a habitat can inflate or unfold, solar panels can deploy, and systems can begin working. From outside, that looks like success. But inside, success depends on whether human beings can wake up there day after day and still feel that life is worth living there. Not only the mission, life. That is a much harder question. It does not have one answer. Some may thrive, some may break, some may adapt slowly, some may feel proud in public and lonely in private. Some may become attached to the base, some may count the days until return. The moon's psychological environment would not be uniform, because human minds are different. But the environment would press on all of them in some way. The pressure would not come from air. It would come from awareness. Awareness of dependence. Awareness of confinement. Awareness of distance. Awareness of Earth. That last awareness may never leave. The planet would remain the great comparison, the visible opposite of the place they inhabit. Earth. Wet. Loud. Breathing. Changing. Messy. Alive. The moon. Dry. Silent. Sealed. Static. Controlled. Exposed. The more beautiful Earth looks from the moon, the more clearly the moon reveals what it lacks. And perhaps that is why a moon base may be emotionally powerful enough to change people permanently. To live there would be to understand Earth not as an idea, not as a planet in a textbook, but as the fragile living exception it is. Every glance at home would be a reminder that humans are creatures of that world. Every technical system in the base would be an artificial replacement for something Earth gives naturally. Every moment outside would prove how rare a breathable world really is. The moon might make humans love Earth more, but it might do so by making them homesick. That is the quiet cruelty. A lunar base would be close enough for Earth to remain visible, close enough for voices to arrive quickly, close enough for return to feel possible, and yet far enough that no human can simply leave the habitat and go home. The crew would live beneath the most beautiful reminder in the sky, while depending on machines to survive on a surface that offers almost nothing. That is not the fantasy of effortless expansion. It is a far more human story, a story about ambition and longing, engineering and homesickness, a new world and the old one hanging above it. And once that strange closeness is understood, Mars begins to look different. Not safer, but perhaps more like a world. That distinction matters. Mars is not a gentle place. It is cold, dry, distant, dusty, irradiated, and separated from Earth by a journey so long that rescue becomes almost impossible in the immediate human sense. A crew on Mars would be far more isolated from Earth than a crew on the Moon. Messages would take minutes to cross the distance. Supplies would be harder to send. A medical emergency would be terrifying. A return home would depend on launch windows, working spacecraft, fuel, and months of travel through interplanetary space. In many obvious ways, Mars is worse, and yet the Moon may feel harsher in a different way. The sky is black, the shadows are harsh, the silence is deeper, the Moon's clock is stranger. Long sunlight, long darkness, artificial day inside a base, a rhythm imposed by machinery rather than received from the sky. On Mars, a person could wake to morning light, even if that light passes through a thin, dusty atmosphere and cannot warm them enough. They could mark time by sunrise and sunset. They could see the sky change color. They could watch dust move. They could feel, through instruments and habitat windows, that the planet has a cycle. On the Moon, time must be built indoors because the outside rhythm is too alien for ordinary life. A Moon base may always feel like an outpost. A Mars base, despite being farther and more dangerous in logistical terms, may more easily become a settlement in the human mind. The horizon extends. The planet surrounds you. You do not see Earth as a large, unreachable home above the landscape. You see a world under your feet, a sky over your head, and a distance from Earth so complete that the mind may eventually stop comparing every moment to home. That could be painful in another way. It is about worldliness. Mars has worldliness. The Moon has proximity. Proximity is useful for engineering, logistics, and early missions. But worldliness may matter for the human mind over years or generations. A person can live in a difficult place if the place becomes meaningful. Mars offers more material for meaning. A red dawn, a valley edge, a distant mountain, a seasonal frost, a dust storm on the horizon, a route between habitats, a place where a rover once broke, a hill where someone watched sunset, a greenhouse that becomes the first green room on a red planet. The moon can have meaning too, but its meaning may be more tied to Earth, science, and the achievement of survival. The moon's landscape is powerful, but it is also severe. Its beauty is almost too pure. A moon base could become a workplace. A Mars base could begin to feel like a frontier. But the title is not about which place is objectively easier in every category. It is about the possibility that the moon, despite being closer, may be emotionally, physically, and operationally worse than people expect, while Mars, despite being far away, offers certain world-like qualities the moon does not. The comparison works because the obvious answer is incomplete. Closer is not the same as more livable. Farther is not always the same as more alien to the mind. Sometimes, the nearer place feels emptier. Sometimes, the farther place feels more like a world. The thin atmosphere of Mars is a good example. For human survival, it is almost useless without technology. It is too thin, too cold, and not breathable. But psychologically and environmentally, it changes the experience. It gives Mars skies, winds, dust movement, and weather. It means the planet has surface processes that are still active. It creates sunsets, hazes, storms, and a visual softness the moon lacks. Even a deadly atmosphere can make a place feel less like raw space. On the moon, space feels immediate. The black sky is not above an atmosphere, it is simply there. The surface is exposed to the vacuum. Shadows are severe. The horizon is close because the moon is smaller. The entire world can feel compact, silent, and empty. Mars, with its larger size and atmosphere, may give a stronger feeling of standing inside an environment, even if that environment is hostile. Humans may need that feeling. The moon is a place to work from. Mars may be a place to live toward. Stepping stones are useful, but they are not always homes. This may also affect how people endure isolation. On the moon, isolation is mixed with constant awareness of Earth. On Mars, isolation is more complete, but perhaps more coherent. If you are truly far away, the mind may accept that life is now organized around the new world. If you are close enough to see home, but still trapped in a sealed habitat, the mind may keep reaching backward. The moon may make return feel always imaginable and always delayed. Mars may make return feel so distant that the present life must become real. It may be crushing, but it may be crushing in a way that allows identity to form around permanence. A person on Mars may begin to think of themselves as someone living on Mars. A person on the moon may struggle between being a lunar resident and being an Earth person temporarily stationed just outside home. That difference could shape everything from crew morale to long-term culture. The moon may be Earth-adjacent. Mars may be world-building. That is why Mars might feel more like a world despite all its danger. It has enough separateness to invite a new story. It is not simply an outpost in Earth's sky. It is another planet with its own day, weather, geology, and history. It once had flowing water. It may preserve clues about ancient habitability. It has mountains larger than anything on Earth and canyons that dwarf our familiar landscapes. Its past feels like a planetary mystery, not only a technical challenge. The moon also holds deep history, especially about the early solar system and Earth-Moon formation. But its surface does not offer the same feeling of a world that once might have been alive with water. Mars does. That matters for imagination. A place with a lost past can feel like a place with a possible future. A place that seems always barren can feel harder to emotionally settle. Mars feels dead, in one way, but it also feels like something happened there. The moon feels ancient, but almost static. That difference is powerful for storytelling and perhaps for real life. People need narratives to endure hardship. On Mars, the narrative might be about restoring, understanding, or surviving on a planet with a lost warmer past. On the Moon, the narrative might be about building a technical foothold on a world that has always been airless and exposed. Both are noble, but they feel different in the human chest. One feels like entering a silent machine room of the solar system. The other feels like standing on a ruined planet. A ruined planet may be easier to emotionally inhabit than a perfect emptiness. Still, Mars's world-like quality can be dangerous because it can seduce people into underestimating it. A red sky does not mean breathable air. A horizon does not mean safety. A day-night rhythm does not mean habitability. Ancient riverbeds do not mean present water is easy to use. Mars can feel more like a world and still be deadly. That is why this comparison must stay balanced. Mars is not the comforting answer to the Moon's cruelty. It is simply cruel in a different shape. But the shape matters. If humans had to choose where a place might one day feel like a settlement rather than a station, Mars may have advantages that numbers alone do not show. Its larger landscape, daily rhythm, atmosphere, and planetary identity could support a deeper sense of life unfolding there. The Moon may remain more useful as a test ground, resource site, science station, and gateway, while Mars becomes the place people imagine trying to make into a long-term branch of human civilization. The Moon may be easier to reach. Mars may be easier to imagine belonging to, once you are there. That statement is not certain. It is a possibility. The first people who live on the Moon may feel a deep belonging no one can predict. The first people on Mars may feel terrible loneliness. No romance can survive. Real human experience will be more complicated than any outline. But the contrast helps reveal why the Moon should not be assumed to be the easier home. It may be easier to visit, easier to supply, easier to communicate with, and easier to leave, while still being harder to psychologically inhabit. The Moon gives support from Earth. Mars gives separation from Earth. Support is useful. Separation may be necessary for a new world to feel real. A lunar base may spend much of its life looking back to Earth for supplies, decisions, communication, emotional meaning, rescue, and identity. A Martian settlement may also depend on Earth, especially early on, but the distance may push it toward autonomy more quickly. The farther world may force the development of a more complete local life, because there is no choice. The nearer world may remain in a permanent half-state, beyond Earth, but never free of Earth's immediate presence. That half-state is the strange territory of the Moon. It is not Earth. It is not deep space. It is not a planet. It is not a natural home. It is close enough to reach, but harsh enough to resist. It is visible every night, but almost impossible to make comfortable. Mars, by contrast, is more clearly elsewhere. Its difficulty is part of its identity. A person who goes there knows they are leaving the Earth-Moon neighborhood for another planet. That clarity may be frightening, but it may also help the mind. The Moon's ambiguity may be harder. Always near, always alien, always reflecting Earth's light, always reminding us that closeness did not make it ours. This is why Mars begins to look different after thinking about the Moon. Not safer, not easier, not more forgiving, but perhaps more complete. A complete world can be hostile and still offer the mind something to build around. The Moon offers a surface and a view of Earth. Mars offers a planet. That single word carries weight. Planet means weather, geography, horizons, cycles, regions, history, and the possibility of local identity. The Moon has history and geography too, but the experience of it is more stripped down, more exposed, more dependent on the base as the only true environment. On Mars, the outside may still feel like a place. On the Moon, the outside may always feel like a warning. That is the emotional core of this comparison. A moon base would constantly show humans how little the surrounding world supports them. A Mars base might also show that, but it may leave room for the feeling that a hard world surrounds the settlement, not just an empty surface. The difference between a hard world and an empty surface may become enormous over time. People can form relationships with hard worlds. Emptiness is harder, and yet, the moon's emptiness is exactly why humans may go there first. It is a nearby laboratory for the hardest questions: how to make air, how to manage heat, how to handle dust, how to extract water, how to protect mines, how to build systems that do not rely on Earth's background comfort. The moon may not be the place that feels most like a future home, but it may be the place that teaches humans what home actually requires. That teaching may be painful. Mars can look like the dream. The moon reveals the machinery behind the dream. It shows that leaving Earth is not mainly about distance. It is about replacing a planet. Mars, with all its danger, gives the illusion of a new planetary context. The moon strips the illusion away. It says, before you imagine living on another world, understand what must be built to keep one human body alive on a world that gives nothing easily. That is why Mars may look better after the moon is understood. Not because Mars is gentle, but because Mars at least offers a world to struggle with. The moon offers a surface to survive on. The two are not the same. A human settlement may need both experiences, the nearby harshness of the moon and the distant worldliness of Mars. But if the question is which one might feel worse to live on, the answer is no longer obvious. The closer world may feel more alien. The farther world may feel more complete. And once Mars begins to feel like a world in comparison, the moon base itself begins to look less like a future city and more like something far more fragile. A place that may never truly feel like home. That is not how people usually imagine it. In the dream, the first moon base glows warmly against the grey surface. There are windows facing Earth, quiet corridors, soft lights, perhaps plants growing under glass, astronauts moving calmly between modules, and a feeling that humanity has finally made a small village beyond Earth. From far away, it looks peaceful. It looks clean. It looks like the beginning of a new chapter, where the moon stops being only a place to visit and becomes a place where human life can take root. But the first real base would probably feel very different from that dream. It would not begin as a city. The floor might hide cables, tanks, structural supports, thermal layers, storage compartments, and vibration paths from machinery. The walls would not just divide rooms. They would hold the artificial atmosphere inside. A door would not just connect spaces, it could separate pressure zones. A window would not just offer a view, it would be a carefully engineered boundary between the crew and vacuum. Even the quietest room would be part of a machine that must keep functioning. Then, it may become everything. One reason is space. The first moon base would probably be small compared with any home on Earth. Every kilogram launched or assembled there would matter. Rooms would serve multiple purposes. Storage would be carefully organized. Personal space would be limited. Privacy would be difficult. The crew would live near the systems that keep them alive, near each other, near the noise, near the work. There may be no true outside to escape into, no private walk, no open street, no garden, no room where the moon is not present in some way. Even silence would not be open. It would be enclosed silence. It might appear during ordinary moments. A crew member wakes up and hears the fans before remembering where they are. Someone reaches for water and thinks about recycling. Someone looks at a sealed hatch and knows the other side is not a hallway, but vacuum. Someone sees Earth through a window, while eating packaged food under artificial light. Someone tries to sleep while a system cycles in the war. Someone misses the sound of rain so intensely that a recording does not help. This is how alien life can become. Not through monsters. A moon base may begin by separating people from the place around them. That is another reason it may not feel like home. A home on Earth usually has some relationship with its environment. Even an apartment in a city connects to streets, weather, people, seasons, and sounds. A cabin connects to forest. A farm connects to land. A house by the sea connects to wind and water. The place enters the home through light, smell, temperature, noise, routine, and memory. On the moon, the environment cannot enter freely. It must be kept out. The first lunar base may live in that in-between state for years. That in-between state might be useful. It could support science, test technologies, produce resources, prepare for Mars, and teach humans how to work in deep space environments. But usefulness is not the same as warmth. A factory can be useful. A laboratory can be useful. A military outpost can be useful. A base can be one of the most important places humanity has ever built and still not feel like a place where people would want to spend their lives. Beautiful and claustrophobic. Close to Earth and impossibly separate. The contrast may never disappear. This makes the idea of home complicated. Maybe home is not only a natural environment. Maybe home is wherever humans create safety, memory, and connection. If so, a moon base could become home in a limited but real sense for some people. It could be the place where they did meaningful work, formed intense friendships, saw Earth in a way almost no one else has, and lived through days that changed them permanently. It gives achievement. It gives silence. It gives the most powerful view of Earth imaginable. But it does not give the basic environmental welcome that humans associate with home. The moon may not allow that easily. Even leisure would be shaped by the base. Exercise would be required not only for health, but as a countermeasure against reduced gravity. Meals would be constrained by storage, recycling, and supply. Sleep would depend on lighting, noise control, and confidence in systems. Recreation would happen in a limited space. Private emotion would unfold near other people. Arguments would have nowhere to go. Boredom could become serious. Small annoyances could grow because the environment does not offer release. A lunar base would have to manage not only danger, but mood. Mood may sound soft, but in long-duration missions, mood becomes operational. A tired, irritated, lonely, or depressed crew is not only suffering personally. They may make worse decisions, communicate poorly, miss details, or struggle with cooperation. In a place where maintenance and attention are survival tools, psychological health becomes mission safety. The base must be designed for human minds, because human minds are part of the system. People often think of space settlement as a hardware problem. It is also a human problem. A module can be sealed perfectly and still feel oppressive. A life support system can work perfectly and still produce noise that wears on people. A schedule can be efficient and still leave no emotional space. A crew can be highly trained and still experience conflict, homesickness, and fatigue. A window can show Earth and still make someone feel trapped. The success of the base would depend on details that do not look dramatic in diagrams. A soft sleeping area, a quiet hour, a private conversation, a real meal, a plant that survives, a place to sit without working. These may become as important to the feeling of home as the larger systems, not because they replace oxygen and water, but because oxygen and water only keep the body alive. A home must also protect the person inside the body. The moon makes that protection difficult, because everything around the base tells the person they are somewhere life does not belong naturally. And yet, The very difficulty may create a powerful kind of attachment. People often become deeply bonded to places where they endured something difficult. A first lunar crew may remember the base with love, precisely because it was hard. The cramped rooms, the noise, the procedures, the view, the fear, the humor, the teamwork, the fatigue, all of it may become part of a shared identity. The base may not feel like home in the usual sense, but it may become a home of memory, a place that shaped the people who lived there. That is the strange beauty of it. The moon may not offer home. Humans may still make one inside it. But making one is not the same as finding one. The first base would not be a natural home waiting for human arrival. It would be an artificial home, built against the evidence of the environment. Its warmth would be chosen. Its rhythms would be designed. Its comforts would be deliberate. Its safety would be maintained. Its meaning would be created by the people inside, not granted by the moon outside. That difference is the heart of the issue. On Earth, home can grow gradually from place, climate, community, and routine. On the moon, home would have to be engineered first and emotionally earned later. Before memory comes pressure control. Before comfort comes insulation. Before community comes life support. Before belonging comes survival. The order is reversed. This reversal could make early lunar life feel psychologically heavy. The crew would know they are part of something historic, but history does not always make a room feel warm at night. They would know the mission matters, but purpose does not always erase confinement. They would know Earth is watching, but being watched can increase pressure. They would know they are safe as long as systems work. But as long as systems work is not the same as feeling safe in the deep, animal part of the mind. That deep mind evolved on Earth. It understands wind, rain, darkness, shelter, fire, voices, trees, water, distance, and open land. It does not naturally understand a sealed aluminum habitat under a black sky, surrounded by vacuum, with Earth hanging far above a grey horizon. Training can prepare the rational mind. Experience can build confidence. But somewhere beneath that, the body may continue to know that outside is wrong. That feeling may be hard to remove. A person may not panic. They may function well. They may even love the mission. But the body keeps score of environments. The moon's environment would be unlike anything in human ancestry. No atmosphere, no biosphere, no weather, no sound beyond the suit, no open safety, no natural food, no water cycle, no living landscape. The base would be the only pocket where the body's expectations are partially met. That pocket may become precious, but it may also feel thin. A thin home is still a home, but it is not a deep one. A deep home is supported by layers: room, building, neighborhood, land, climate, planet, living world. On the moon, many of those layers are missing or artificial. There may be a room and a habitat. There may be a crew. There may be routines and mission culture. But outside the habitat, the layers drop away quickly into vacuum and dust. The sense of being embedded in a living world is gone. That absence may be the defining emotional fact of the first moon base. It may never fully feel like home because there is no surrounding world to hold it. The base holds itself. That image is both fragile and magnificent. A small human structure holding its own air, its own warmth, its own water, its own light, its own rhythm, its own meaning, while resting on an ancient surface that has never needed any of those things. It would be one of the most extraordinary contrasts ever created. Life inside, lifelessness outside. Voices inside, silence outside. Memory inside. Geological time outside. The first moon base would be a candle under glass. Beautiful, because it survives. Lonely because it must be protected from everything around it. If people ever live there long enough, maybe that feeling will change. Maybe future bases will be larger, quieter, more comfortable, more shielded, filled with plants better designed for privacy and community. Maybe children will one day see the moon not as a hostile outpost, but as the place where they were born. Maybe tunnels, covered habitats, artificial parks, and local culture could slowly transform the meaning of lunar life. But the first base would not be that future. It would be the hard beginning. It would be the proof that staying is possible before staying is comfortable. It would be the stage where the moon still feels raw, where every system is watched, where the idea of home is fragile, and where the people inside understand that they are living at the edge of what human technology can make survivable. That may be more honest than the dream. The dream shows a city. The beginning gives a machine. And inside that machine, people would try to live softly. They would try to make meals feel normal. They would try to make sleeping feel safe. They would try to make walls feel warm. They would try to make routine feel like life rather than procedure. They would try to make the moon something more than a workplace. Some days, they might succeed. Other days, the base may feel like exactly what it is, a sealed outpost on a world that does not know they are there. That is not a failure. It is the first step, but it is a first step stripped of romance. A moon base would not be worse than Mars because it is useless, or because the dream is foolish. It may be worse because it sits in the most painful middle ground, close enough to Earth to feel like it should be easier, harsh enough to make every comfort artificial, and empty enough that even success may not feel like home. A place can keep humans alive without making them feel they belong. The first moon base may be exactly that. A shelter, a station, a machine, a candle under glass. And once we understand why the first moon base might never feel like home, the final question becomes why humans may still build it anyway. Because difficulty has never been enough to stop the human mind from looking outward. If the moon is harsh, that does not make it meaningless. If it is airless, dusty, cold, exposed, and psychologically strange, that does not make it useless. In some ways, those very dangers are what give it value. A gentle world would teach us less. A comfortable place would hide fewer truths. The moon is close enough to reach, but hostile enough to reveal what living beyond Earth really demands. It is near enough for humanity to practice, and severe enough that the practice would matter. Not because the moon is easy. A moon base would become a place where humanity learns what cannot be learned from drawings, simulations, and short missions alone. Engineers can test systems on Earth, but Earth always interferes with the lesson by being too kind. Gravity is stronger. Air is everywhere. Spare parts are easier to obtain. Medical help is nearby. Weather can be dangerous, but the planet is alive and thick with support. Even the most isolated test site on Earth remains on Earth. The moon removes that comfort. It is a laboratory where the environment does not forgive human convenience. A habitat there would have to work in real vacuum, real dust, real radiation, real reduced gravity, real thermal extremes, and real isolation from Earth's immediate physical help. That makes it one of the most powerful testing grounds humanity could use before trying to live farther away. A moon base may be uncomfortable precisely because it is close to the truth. That is important. A base on the moon can fail in ways that teach without becoming the end of the whole dream. Systems can be redesigned, crews can rotate, equipment can be replaced more often than on Mars. Emergency planning is still severe, but the distance is smaller. The moon gives humanity a harsh world inside a reachable neighborhood. It lets us discover how bad our ideas are before we depend on them across interplanetary space. That may sound cold, but it is wise. Civilizations do not become spacefaring by wishing the universe were softer. They become spacefaring by learning how hard it is and building anyway. The moon is a place where that learning can become physical. Every module landed there, every airlock cleaned of dust, every liter of water recycled, every power problem solved, every crew rotation completed, every repaired rover, and every successful surface operation would become part of a larger education. It would be a school for survival beyond Earth. But it would also be more than that. The moon is scientifically valuable in its own right. Its surface holds records of ancient impacts, solar wind, volcanic history, and the early relationship between Earth and its companion world. It is not just an empty platform waiting for human use. It is an archive. By studying it carefully, humans can learn about the early solar system, the violence that shaped young planets, and the history of our own world. That memory is written in craters, rocks, dust, basins, and frozen shadows. The surface is old in a way Earth's surface often is not, because Earth constantly renews itself through plate tectonics, weather, oceans, erosion, and life. The moon preserves scars. It holds evidence across vast stretches of time. A permanent human presence there could turn the moon from a place of brief footprints into a long-term observatory of planetary history. There is also the sky. This is why the answer cannot be only fear. The moon is not easy, but ease was never the true reason to go. The true reason is that the moon sits at the edge of human capability. It is the nearest place where Earth's protection is gone, and that makes it a mirror. It shows us what we are without our planet. Small, fragile, inventive. A moon base would expose all of that at once. It would show that human beings are not naturally suited for space, and then show that we can still build systems that let us enter it for a while. It would reveal dependence on Earth, and then slowly develop the skills needed to reduce that dependence. It would show that another world does not become ours just because we arrive, and then force us to earn every meter we occupy. That is a humbling kind of exploration, a negotiation with reality. The first base may be small, it may be cramped, noisy, difficult to maintain, and far less beautiful than the images in our minds. It may feel more like a machine than a home. The people inside may miss Earth more deeply than they expected. Dust may become maddening. Water may be harder to extract than predicted. Systems may fail in boring and expensive ways. The moon may resist being turned into a simple story of progress. It would matter because it represents the moment human life stops being only a visitor on another world. A landing is a touch. A base is a decision to remain. Even if that remaining is fragile and temporary at first, it changes the relationship. The moon would no longer be only a bright object in the sky, or a place crossed by a few astronauts long ago. It would become a place where human beings wake up, work, repair, worry, learn, and look back at Earth from the outside. Every time humans live beyond Earth, even briefly, the meaning of Earth changes. The planet stops being the unquestioned background and becomes something visible, limited, and precious. From the moon, Earth is not an idea. It is a world in black space. A moon base may make people feel homesick, but homesickness can carry wisdom. To miss Earth from the moon is to understand that Earth is not ordinary. It is a rare environment where life does not need to hide inside machines. That realization may be one of the greatest gifts of a lunar base. It may teach space settlement, it may teach planetary science, it may teach engineering, but it may also teach gratitude. The moon is often described as the first step away from Earth. It may also become the place where humanity learns how deeply it belongs to Earth. Every sealed room, every artificial breath, every stored liter of water, every shielded sleeping area, every recycled drop, every careful EVA, would point back to the planet that gives those things freely. Not because Earth is infinite or indestructible, but because Earth is the only place we know where life is held by the world itself. A moon base would be a monument to Earth, as much as a step away from it. That makes the dream more meaningful, not less. If humans build there, the goal should not be to pretend the moon is comfortable. The goal should be to understand the cost and build with respect. Respect for the environment, respect for the science, respect for the people who will live inside those fragile systems, respect for the fact that space does not become safe because it becomes familiar. The moon is familiar from Earth. The surface is not familiar to life. If humans go with humility, the moon could become a powerful beginning. Not a new Earth, not a simple colony, not a clean science fiction city, but a hard first foothold in the real universe. A place where the dream is stripped down and tested. A place where every success is earned. A place where humanity begins to learn whether it can carry life beyond the planet that created it. The first base will not answer everything. It will not make humans a multiplanetary species overnight. It will not remove the dangers of Mars. It will not solve radiation, psychology, economics, resource use, or long-term settlement by itself. But it may begin the process. It may create the first operational knowledge that only comes from staying somewhere hard. It may turn speculation into experience. Experience is what space dreams lack until someone goes. A moon base would give humanity experience at the edge of Earth's reach. It would teach what breaks, what works, what people need, what machines tolerate, what dust does over time, what water extraction really costs, what isolation feels like when Earth is visible, and what kind of culture forms inside a sealed habitat. Those lessons would not be glamorous every day. Some would be frustrating, some would be expensive, some would be painful, but they would be real. And real lessons are worth more than beautiful assumptions. Not because the moon is better than Mars in every way. Not because the moon is waiting to become home. Not because it will be comfortable, simple, cheap, or safe. But because it is close enough to teach us and harsh enough to matter. The moon may become the first place where humanity seriously confronts the difference between visiting space and living in it. Visiting is bravery. Living is endurance. Visiting requires a mission. Living requires a system. Visiting can be planned around return. Living has to face repetition, boredom, maintenance, failure, fatigue, and the slow transformation of danger into routine. That is the deeper threshold. A moon base is not just a structure on another world. It is a question placed on the surface. Can human life persist where a planet does not support it? Can we build enough, learn enough, cooperate enough, and care enough to keep a tiny pocket of life alive in a place that never asked for it? The answer may begin with one habitat, one crew, one airlock, one power system, one water loop, one window facing Earth. From the outside, it may look small, almost fragile, a few modules on a gray surface under a black sky. But inside, it would contain something enormous, the attempt to detach a piece of Earth's living conditions and carry them into the silence. That attempt is both terrifying and beautiful. Terrifying because it shows how little the moon gives us. Beautiful because it shows what humans will try when the night sky is no longer only something to look at. A moon base would be worse than Mars in ways we do not always expect. It may be more sterile, more exposed, more psychologically strange, more dependent on Earth's visible presence, and more difficult to make emotionally livable. It may feel less like a new world and more like a sealed machine resting on one. It may never become a true home in the way people imagine when they look up at the moon from a quiet street on Earth. But perhaps that is why it matters. It is not the easy dream. It is the honest one. Before humans can imagine cities on Mars, ships between planets, or settlements under alien skies, we may need to face the nearest world and discover how hard even that will be. The moon removes the fantasy that space is waiting for us. It is not waiting. It is silent. It is cold. It is dusty. It is beautiful. It is indifferent. And still we may go. We may go because curiosity is not satisfied by safety alone. We may go because knowledge has always required crossing difficult boundaries. We may go because the moon can teach us how to survive elsewhere, and because surviving elsewhere may change how we understand home. We may go because the sight of Earth from the moon can break something open in the human mind, the realization that all our oceans, weather, forests, cities, and lives are held on one small world in darkness. A moon base would not make the moon kind. It would make humanity more aware of danger, aware of dependence, aware of Earth, aware that the universe is not built for us, and that any life we carry into it must be protected with extraordinary care. That awareness may be the beginning of real space civilization, not the fantasy of effortless expansion, but the discipline of fragile survival. Not the idea that humans can simply move into space, but the understanding that every step away from Earth must carry responsibility with it. Responsibility to the crew, to the science, to the worlds we touch, and to the planet that made us. So perhaps the moon base would be worse than Mars. Perhaps it would feel colder, closer, stranger, and less like a world. Perhaps it would never truly feel like home, but it may still be the place where humanity learns what home really means. A home is not only where humans can stand, it is where the world helps them live. And on the moon, for the first time, we would have to build that help ourselves. Thank you for watching this calm journey into the harsh truth of building a moon base, and why our nearest world may be far more difficult to live on than Mars. If you enjoyed this documentary, subscribe for more quiet space stories like this. Leave a like if you want more deep journeys into the mysteries of the universe, and write in the comments where you are watching from. Tonight, you are watching the Space for Sleep channel, talking about why building a moon base would be worse than Mars. Sleep well and keep looking up. Good night.